Great, welcome back to the Psychosis Series. In this video will be a continuation of the cognitive model of psychosis. This video will really be getting at the heart of what occurs cognitively when psychosis is occurring. Ideas presented here will apply mostly to schizophrenia and bipolar with psychotic features, but it will lay the framework for understanding psychosis in any condition or drug. Quick overview what I'll be going over in this video. First, I'll be discussing dopamine and what it encodes in the brain. Then I'll be talking about psychosis and dopamine's role in psychosis, and then I'll just be discussing the common symptoms that occur in psychosis. So delusions, especially delusions of control, hallucinations. And then I'll present why duration of untreated psychosis is important, and then understanding what the treatments actually do in the brain. First, let's talk about what dopamine actually is. Think about it, it's actually pretty crazy. I hear people talk about dopamine all the time, and they reference antipsychotics and its role in schizophrenia and its role in substances, but I never actually hear people talk about what dopamine actually is. There have been multiple hypotheses for what dopamine actually does. People know that dopamine is central in reward and reinforcement, and there's also the anhedonia hypothesis that dopamine is the mediator of life's pleasures. But this doesn't really give the full picture because dopamine is also released with aversive stimuli. And keep in mind that dopamine release precedes the consummation of pleasure. It's seen during the anticipatory phase of reward, regardless of the actual final payoff. So of course it's simplified, but I think it's funny that our understanding of neurotransmitters, we have serotonin for happiness and dopamine for pleasure. If it were really that simple, I would just be doing drugs all the time to keep my dopamine and serotonin up. And I tried that in college and it didn't work out well. So yeah, there's more to it. So dopamine is responsible for what's called the attribution of salience. Dopamine mediates the conversion of a neural representation from a neutral and cold bit of information into an attractive or aversive entity. Kind of reminds me of Photoshop, how you can take three numbers and it actually generates a pretty color like pink. So here the neutral cold bit of information is the three numbers 255, 100, 236, and then the attractive entity is the actual pink color that sticks out to you. So think of the numbers as pre-dopamine and the pink as post-dopamine. So here we can understand the mesolimbic system as a critical component of the attribution of salience. So what is salience? Salience is the process where events and thoughts grab attention, they drive action, and they influence goal-directed behavior. With this in mind, we can connect why it was previously understood as hedonic pleasure, or its role in motivation and reward and learning and addiction, and that's because salience allows organisms to focus on what's valuable and converts motivation into action. So an example of saliency is a bull being drawn to a red sheet. In this group of apples, which one is salient to you? So to me, it's the red one. It sticks out. So a stimulus that evokes dopamine is one that has salience, and the dopamine firing will grab your attention, it will drive your action, it will influence your behavior, it will demand an explanation or an updating of a belief. Now I want to connect dopamine to the predictive processing model that I presented in the last video. What dopamine literally encodes for is the precision or uncertainty of prediction errors. If you recall, prediction errors are a mismatch from our top-down and bottom-up models. So it occurs when there's a mismatch between our expectation in our models and the actual inputs and sensation. Dopamine codes for narrowed confidence intervals for this mismatch. So during the handshake, your brain recognizes that these things are different, and then dopamine tells you how different they actually are. So imagine you're hiking in the woods and you're expecting to see a bunch of leaves because that's what your model's predicting. And these are the two different things that you see. So the butterfly on the left is going to release a lot of dopamine. So how I like to imagine this is your brain is asking the question, how sure are you of this mismatch? And at the center, your brain's like, yo, I'm 100% sure. This is a lock. Something's weird going on here. But at the edges, you're like, yeah, you know, maybe something's different. I don't know. So picture the butterfly on the left. So your brain is very confident that something's different. So a lot of dopamine's released, and that's a small little confidence interval. So your brain's saying, I'm really sure that something's going on here. And on the right, your brain is like, well, you know, it looks a little different than we expected, but we're not really too sure. So only a little bit of dopamine is released, and there's a wide confidence interval. So the butterfly on the left, you can tell, really sticks out. It's a very salient butterfly. Your brain is telling you, we didn't expect to see this color in the wild. And because you don't expect to see this brilliant color blue in the wild, your brain releases a lot of dopamine, and this butterfly really draws your attention. And you can compare that to the butterfly on the right, which looks a lot like the leaves above. So only a little bit of dopamine was released because it didn't completely contradict your model. And as a result, the butterfly doesn't really draw your attention as much. So to summarize, dopamine firing encodes the precision of the uncertainty of the prediction errors. And because prediction errors are a big deal, your brain processes high prediction errors as very salient. And things that are very salient will draw your attention, they'll drive action, and they'll influence goal-directed behavior. Ultimately, will demand an explanation or an updating of your belief systems. And that's why if you were walking in the woods, this bright blue butterfly would catch your attention even even if you weren't looking for it. Whereas the green butterfly you might entirely miss even if you were looking for them. So now that we have a better grasp of what dopamine actually encodes, we can understand psychosis much better. So psychosis occurs when dopamine, which should be acting as the mediator of salience, becomes the creator of salience. So the proper sequence of events is our brain detects something salient, or it's a big deal. Then dopamine should increase correspondingly, and then we respond appropriately. So this sequence of events is the stimulus-linked release of dopamine, which is just how our brains normally work. Here, dopamine mediates the acquisition and expression of appropriate motivational saliences, which is contextually driven and based off of stimulus, so it occurs appropriately. So now, the best way to view psychosis is that dopamine is now the creator of the salience. So a psychotic individual has dysregulated dopamine transmission, which leads to stimulus-independent release of dopamine. So this means that things that shouldn't be a big deal are going to be incorrectly assigned salience. So now the sequence is dopamine gets increased for no contextually relevant reason. Our brain interprets the increase in dopamine as, of course, a big deal because it's considered salient. So to repeat myself, the dopamine aberration takes over the normal process of contextually driven salience. And this leads to inappropriate assignment of salience to external objects and internal representations. And to repeat myself, dopamine, which should be the mediator of salience, becomes the creator of salience. So with this in mind, let's look at an example of what occurs when someone's actively psychotic. So the basic story of psychosis is that it creates waves of anomalous prediction error and surprisal and leads to delusions of significance, where someone who's psychotic believes some mundane event is some incredibly important cosmic message. And then the psychotic person's brain tries to produce hypotheses that will explain all the prediction errors and reduce the surprisal. But this is, of course, impossible because the prediction errors and the surprisal is random. It's not contextually driven. So this can lead the psychotic person to incredibly weird hypotheses, and even possible to ignore the bottom upstream entirely, which would be hallucinations. So let's visualize someone with aberrant dopamine release and imagine that they have some aberrant prediction error and are incorrectly surprised by some sense data. So imagine a fly lands on that person and their brain shouts, "Whoa, I was not expecting that. That changes everything." So maybe this happens once and your brain is able to ignore it. So they'll think, that was a really significant event, but whatever, I'll go on with my day. But then another mundane event happens and your brain again says, "I was not expecting that." So imagine this happening 30 times in one day. So then completely unconsciously, your brain starts to shift its resources to coming up with theories of the world that explains why these mundane events were super important. And since your brain is prioritizing explaining the particular fly at the cost of everything else, sometimes you develop ideas and delusions that just make no sense. So as a psychotic person encounters more and more strange things, they almost rationally alter their higher level beliefs further and further. And the more aberrant events that they're forced to explain, the more they abandon their sane views about the world, which are now doing a very bad job at predicting all these strange things that are happening to them, and they start to adopt psychotic views. And if you take a person who's schizophrenic, so they're in psychosis for a long period of time, they're going to need to develop a set of beliefs that must account for a great deal of strange and completely weird contradictory data. And I kind of like the creepiness in this one quote from a Frith and Fletcher paper. If one imagines trying to make sense of a world that has become strange and inconsistent, pregnant with sinister meaning and messages, the sensible conclusion might well be that one is being deliberately deceived. This belief might also require certain other changes in the patient's view of the world. They may have to abandon a succession of models, or even whole classes of models. Ugh, a little creepy. So let's try to visualize this. Imagine at the beginning you have some flies randomly landing on you that you attribute to great significance. So you develop the belief that these flies are landing intentionally on me. And then weeks pass where you have these bizarre experiences, and your belief that you don't matter that much to national intelligence agencies, that kind of gets taken over because you have all these random events that you think are super important. So now you develop the belief that these flies and these random events are being sent by the CIA who's following me. And then imagine years pass and you still have all these aberrant events of great significance that you can't explain. And maybe one possibility to explain why the CIA is following you is because you are Jesus Christ. So in the beginning, you abandoned some beliefs that weren't that big a deal, like flies don't land intentionally on people. But then as time passes on, you start to abandon higher order beliefs that are more important. If you were only in psychosis for a few days, you would probably say a few strange things, but you still would be mostly your normal self. But if you stay in psychosis for a longer and longer period of time, you start to abandon some really important beliefs that are important to function. So now we're going to continue with this idea and make sense of why the common symptoms of schizophrenia, for example, are delusions of control and ideas of reference and hallucinations.